Okay, welcome to this video where we're going to have a look at everything you need to do with circles when it comes to the AS Pure Maths curriculum. And you can see the topics on the screen that we're going to be having a look at. We're going to be looking at midpoints and perpendicular bisectors, the equation of a circle, intersections of straight lines and circles, tangents and chord properties, and circles with triangles. So for this video, we're going to have a look at quite a few topics. It's going to cover the whole of this chapter. And as always, I will link this, all the videos in the description and also show you the chapters. So very quickly before we get started, I will show you how that works. So when you are on one of these videos, hopefully you've seen them before, and hopefully you'll have seen this video here where I cover the entire AS Pure curriculum. Now you'll notice that when you're on one of these videos, there are two things that you can do. You can click into the description, so if we click into that, it will bring up all of the timestamps just to the right here that breaks the video up into chapters. And because it's broken up into chapters, what you can do, you can click on the video, click into the chapters there just down the bottom left, and you can see everything bookmarked for you so that you can just click on any one and it will jump you to that part of the video. So hopefully that's useful and helpful. Don't forget to like the video, don't forget to share it with one of your friends, and let's get started. Okay, so when looking at midpoints and perpendicular bisectors, this is quite a common type of question. So it says the line segment AB is the diameter of a circle centre C, where A is -1,4 and B is 5,2. It says the line L passes through C and is perpendicular to the line AB, which is the diameter. Find the equation of line L. So we want to find the perpendicular bisector of this diameter. And obviously the perpendicular bisector is going to be perpendicular, so we have all our stuff to do with perpendicular gradients. So if we start by finding the midpoint of these two, we might be able to draw a little sketch of this a little bit better. So to find the midpoint, you take the coordinates and add them together and divide it by 2. So if we focus first on the x-coordinate, to get the midpoint of the x-coordinate, we would do 5 plus -1, the two x-coordinates, and divide that by 2. And the other coordinate would be 2 plus 4, and again dividing that by 2. So for that particular coordinate there, 5 add -1 is 4, divided by 2 is 2, and 2 plus 4 is 6, divided by 2 is 3. So we could probably draw an okay sort of sketch and think about what this looks like. So A is -1,4, so -1,4, let's just imagine that's here. And then our coordinate in the centre is 2, 3. So that is to the right, obviously, and just a little bit lower than the 4. And then we've got another coordinate, which is 5, 2, which is to the right again, and just a little bit lower. So it's going to look something like this. Now, obviously, you're not going to be able to draw a perfect sketch of this, but you can just have something to help you visualize it. So if we imagine it looks something like that, although that wasn't very good as my centre doesn't look fantastic, so you can always get rid of these coordinates and just put them back on so it suits your diagram. So let's say it's there, there, and there. So now we have the coordinates of the centre. So we could also draw in this line AB, and let's label that up. So that would be A, and this would be B. And we have our centre point there, and we are going to find the perpendicular bisector. So if we if we draw that in and imagine what it looks like, it's going to look something like that. And it'd probably be also worthwhile labeling on that centre point 2, 3. So how do we go about finding a perpendicular line? Well, first of all, we want to find the gradient. So if we find the gradient of AB, well, then we can go about doing that to start with. So for finding the gradient, y2 minus y1, so that is going to be the y-coordinate of B, take away the y-coordinate of A, over the x-coordinate of B, which is 5, take away -1, the x-coordinate of A. So that comes out as -2 over 6, which is -1/3. So our gradient of AB is -1/3. Which means our perpendicular gradient is going to be our negative reciprocal, and that comes out as +3. So that is the first thing we need, that is the gradient of our perpendicular bisector here. So now we can use our line equation, so y minus y1 equals mx minus x1. and it is going to have to pass through that coordinate through the centre, which we can see here, 2 and 3. So we would have y minus the y coordinate of 3 is equal to m, which is 3. I was about to draw the bracket, let's get rid of that, equals 3 lots of x minus the x coordinate, which is 2. So if we expand that out, we get y minus 3 is equal to 3x minus 6. And then, of course, to finish this off, we want it just to say y equals, so add 3 to both sides. There we go. And we get y is equal to 3x minus 3. And that is the final line equation, and that is the equation of our perpendicular bisector passing through the midpoint of AB. In terms of actually the equation of the circle, I'm always just going to write that down. So I've got x minus a, which is the first coordinate, or the x coordinate within the centre, squared. Add to that y minus b, which is obviously the y coordinate of the centre, squared, and that's going to equal the radius squared. So if we plug these numbers in that we've been given, 3 and 1, let's just put them into the equation. Let's see what we get. So there we go. We've got x minus 3 squared, add y minus 1 squared, and that is equal to the radius squared. Now I'm going to do this in two different ways. So if you've seen this before, you might have only used one of the ways, so I'm going to show you the both. But in terms of what we'd have done at GCSE, maybe at this point, we'd have imagined these two coordinates. Okay, so if I imagine the point 3, 1, which is the centre, it does always help if you can draw a little diagram of these, but if we imagine 3, 1's the centre, and then negative 2, 5, let's just have a little think, it probably looks something like this. There we go. And negative 2, 5 is somewhere over here. Let's have a think. Negative 2, 5 is maybe over there somewhere. There we go. But in terms of looking at these 2 points, we would find the length of the radius by using Pythagoras, like we've just talked about, and we would look at the base, or the rise and the run there, or the change in x and the change in y, and then we just use Pythagoras to work out the radius. So in terms of the base length, it goes from negative 2 on the left there over to 3, which is a length of 5, and going up it goes from 1 up to 5, which is a length of 4. So you can use Pythagoras to work out the length of the radius there, and we can just do that quite nice and easy. We can do 4 squared plus 5 squared, which is 16 plus 25, which is 41. And then you can just square root that for the radius. So r equals the square root of 41. There we go. But obviously we want to know what the radius squared is. So when it's in a nice little square root like that, we can just take away the square root and it'd be 41. So we could finish off our equation here. It'd be x minus 3 squared plus y minus 1 squared equals the radius squared. The radius is root 41, so 41. So it says the circle C has equation, and then we have the equation here in lots of pieces. We've got x squared, y squared, x, y's, and a number, and it all equals 0. It says find the coordinates of the centre of C and the radius of C. And then we've got another question here that says find the coordinates of the points where C crosses the y-axis. So we'll have a look at that in a sec, but this actual equation here has to be rearranged in order to get it into the format that we want. Obviously we know what the format looks like. We've got x minus a in brackets squared, and then we've got y minus b in brackets squared, and that equals r squared. So we have to rearrange this. We need to get all those numbers on the right hand side, and then we need to get these x parts into brackets. And if you hopefully recognise this, you should recognise that this looks very similar to completed square form, and this is where we're going to use a bit of completing the square to get it into this format. Now if we have a look at the pieces that we have in our equation, we've got some x pieces here. We've got, and I'll highlight this in that colour there, we've got the x squared and we've got a minus 6x. Now if we just forget about everything else there and we group those together, we'll have x squared minus 6x. Okay, now if we were to complete the square on that, okay, just on that part there, we would obviously halve the coefficient of x, so it would be x minus 3 in brackets squared. And obviously if you're not sure on completing the square, don't forget I've linked that in the description below, so check that out first. And then obviously we need to get that back to 0 because there's no number after this. So to get that back to 0, thinking about what that would expand to, well, negative 3 times negative 3 would give us positive 9. So I'd also have to take away 9, and that obviously that expression there would give us x squared minus 6x. So that's just writing that in completed square form. We also have the y pieces. Now if we have a look at the y pieces in there, let's just highlight those. We've got y squared and a plus 2y. Now if I put those in, we've got, so I'll put a plus here as well. We've got y squared plus 2y. Now if I complete the square just on that, and let's keep the plus there as well, we would halve the coefficient of y, so I'd get y plus 1. There we go, in brackets squared. And when we expand that, that gives us plus 1, so we have to take that 1 away to make it balance to the expression above, the y squared plus 2y, and that would obviously complete the square on that part. So far, what we've done, we've completed the square there, that's given us a little bit below, and we completed the square for the x parts there, again for that bit below as well. Then we've still got that minus 15, so I need to bring that minus 15 back in. There we go, and it all equals 0. So let's add the minus 15 in. There we go, and that all equals 0. Now if we have a look at just the numbers that we've got there, we've got a minus 9, a minus 1 and a minus 15. Now if I group those all together, and I'll probably skip a few steps on the next question here, but if I group all the numbers together and I'll put them all at the end, let's see what we've got. We've got x minus 3 in brackets squared plus the y plus 1 in brackets squared. And then all of those numbers, we've got minus 9, minus 1, that's minus 10, minus another 15 is minus 25. There we go, and that all equals 0. And obviously just to finish this off, we just need to move that 25 over to the other side, and that'll get it into the equation of a circle, the format that we've looked at throughout the video. So if we plus 25 to the other side, just to finish this off, and then we can get the centre and the radius from that. So we've got x minus 3 in brackets squared plus y plus 1 in brackets squared, and that equals 25. Now from there we can get the coordinates of the centre, and we can also get the radius. Now the easiest part there, well, I think they're both relatively simple once you've got to this point, but it's nice and easy just to square root this number at the end to get the radius. So we know that the radius is going to equal the square root of 25, as that is r squared at the end, equals the square root of 25, and in this case that becomes a whole number, that becomes 5. Okay, obviously the square root of a number is positive and negative, but we can't have a negative radius, so it's just going to be 5 there for the length of the radius. Now in terms of actually getting the equation of, the coordinates for the centre, now obviously we know it's minus a and minus b on these parts here. So a is going to have to be that 3 right there, so the centre. And there we go. We know it's going to be 3, we've taken away 3, and on this one here we just need to be a little bit more careful because we've got a plus 1 there, so we must have taken away negative 1 in order for it to turn into positive 1. And there we go, that's our radius and our centre taken from that equation. Okay, so there's our two key parts for part A. We've got our radius, which is 5, and our centre, which is 3 and minus 1. Just need to be careful there when there is a positive number in the bracket like the y plus 1, that you remember therefore it must have been negative 1 that we took away in order for it to become positive. Now the second part here says find the coordinates of the points where C crosses the y-axis. Now in terms of actually thinking about this logically, in terms of a coordinate graph, if we had a circle, let's think about what this would look like. Let's have a think. The centre is at 3 minus 1, which is somewhere there. And if I was to draw a circle in, which I always don't really like doing on the screen here because it's not the easiest to draw, but it would look something, and it's a really rubbish circle, but there we go, it looks something like that if I was to draw a basic sketch. Let's get rid of that centre point because that really does not make it look good. There we go, let's imagine the centre, there we go, 3 minus 1. Not to scale. But there we go, we have these two coordinate points where it crosses through the axes, so here and here. Now the logical thing about this question is that any point on the y-axis there, the x coordinate down here is always going to be 0. So effectively, if we want to know what the y coordinates are, where it crosses through the y-axis, all we have to do is sub in x equals 0. Let's get rid of that sketch there because it's a little bit of an embarrassing sketch, there we go. But just to give you a sort of an idea as to what we're actually looking at, we're looking at when x equals 0. So if I sub that into my equation, and my equation's there, I just want to know what does it equal when x equals 0. Let's put that in. So when x equals 0, what do we get? And I'm subbing it into this equation just here. So we get 0 minus 3 in the first bracket, so we get negative 3 squared, plus, we don't know the y coordinates, so we've got y plus 1 squared, and that equals 25. So we just need to rearrange this. Now negative 3 squared is 9, so actually I could just think that that's 9 there. And if I take away 9 from both sides, we get y plus 1 in brackets squared equals 16 when you take away that 9. Now if I square root both sides, obviously we want to get y, find out what y is. So square root both sides, we get y plus 1 equals this plus and minus the square root of 16, so it could be plus and minus 4. And obviously then we just need to take away 1 from both sides, and we get y equals minus 1 plus and minus 4. And that there will give us two values, okay, because you could have negative 1 add 4, so y could equal 3, or we could have -1 take away 4, which would equal -5. So we've got 3 or -5 in terms of where it crosses the y-axis. They are the two coordinates there. So obviously you could draw a bit more of an accurate sketch now you know where it crosses through the y-axis. But there we go, that's how we're going to go about solving these two parts of the question. So for this question, looking at intersecting circles with lines, it says show that the line x minus y minus 10 equals 0 does not intersect with the circle, and then we have our circle equation. So we've got our two pieces, and obviously the process to solve this will be using simultaneous equations. So although we looked at quadratic simultaneous equations before, this question is slightly different as it says this fact here does not intersect. And obviously in this relation we are actually looking at the actual circle. So the process to do this is substituting that first equation in, so we want to make that x or y equals. Now look at your circle equation, because there are two x's in that equation, but there's only this one y squared piece. So it would be easier for us if we can make it say y equals. So if we take our first equation and add y to the other side, we get x minus 10, which is equal to y. Of course you could write that as y equals x minus 10. So if we take that and substitute it into our circle equation, just put in a bracket around x minus 10, when we substitute that in, we get x squared minus 4x plus, and then we have our x minus 10, which is going to be squared, and that is equal to 21. So now we have an equation that is going to be a quadratic that we're going to need to make equal to 0, and then to show that it doesn't intersect, we're going to have to show that it has no real roots. So having a look at this then, let's first expand that double bracket, and obviously if you are quick at expanding your double brackets, you can obviously just write the answer to that, which is x squared minus 20x plus 100. So if we write that all out and simplify it, we've got 2x squared, so 2x squared. We've got a minus 4x minus 20x, which is going to be minus 24x. We have a plus 100 at the end, but we're also going to have to minus this 21 to make sure it equals 0. So we can simplify that straight away, which is 100 take away 21, which is going to be plus 79. And that is now equal to 0. Now obviously if they did intersect, at this point we would want to solve this equation. We would want to find our x coordinates, and then we would substitute them back in to find our y coordinates. But this says does not intersect, so we will look at the discriminant. So for the discriminant we are going to look at b squared minus 4ac, and then identify our a, b and c. So a is 2, b is negative 24, and c is 79. And again, it's always worth writing them down. A is equal to 2, b is equal to negative 24, and c is equal to 79. Okay, so putting that into b squared minus 4ac, we are going to have negative 24 squared, and take away 4 times 2 times 79. And if we type that into our calculator, and let's just type that in, we get negative 24 squared minus 4 times 2 times 79, and the answer comes out as minus 56. So we know that when b squared minus 4ac is less than 0, that less than kind of looks a little bit like my c there, but that means it has no real roots. Okay, so because we've got an answer of negative 56, we have no real roots, and therefore these do not intersect. Okay, so when looking at tangents to circles, we just need to remember that the tangent is going to be perpendicular to the radius. So for this question here where it says the point P, which is 1 minus 2, that lies on the circle with a centre 4, 6, and it wants us to find the equation of the tangent to the circle at that point, we can start by finding the gradient of the radius. Now what you can do on a question like this is to draw a little diagram which might help you to visualize it, and that's fine to do as well. It says the center of the circle is 4, 6, if we imagine that that is just there, and there is a point which is across 1 minus 2, let's imagine that's here, and obviously you could draw a sketch of the circle. Again, it doesn't have to be perfect, but it might help you to visualize it. So we are going to find the gradient of this radius that I've just drawn in, and that is between the point 4, 6 and the other coordinate down there, which is 1 minus 2. So obviously you don't need the actual drawing to do that, because we can just use our y2 minus y1 over x2 minus x1. So y2 would be 6 take away minus 2 over 4 take away 1. So 6 take away minus 2 is equal to 8, and 4 take away 1 is equal to 3. So the gradient of the tangent is 8 over 3. That means that the gradient of the radius is 8 over 3. Now we are going to find the gradient of the tangent, because the tangent there is going to have a perpendicular gradient. So we are going to find the perpendicular gradient, which is the negative reciprocal, which is going to be negative 3 over 8. Now we can take that and we can put it into the equation of the line, given that we know it passes through the point 1 minus 2. Okay, so putting that into the equation of a line, we will have y minus y1, which is y take away minus 2, which is going to be y plus 2. So y plus 2 is equal to negative 3 over 8, x minus x1, and x1 is 1, so x minus 1. We can now expand that, so we have y plus 2, which is going to be equal to negative 3 over 8x minus 1 times minus 3 over 8 is going to be minus 3 over 8, but it was times a negative, so it'd be plus 3 over 8. Now we can take away 2 from both sides, or what we could do here, just to make that actually a little bit easier for us, is we could just multiply everything by 8 to remove those fractions, and that's fine for us to do. So we would have 8y plus 16 is equal to minus 3x plus 3. That makes it a lot easier for us to rearrange that, and as now we can just minus 16 from both sides, or we could move everything to one particular side, which doesn't really matter. But if we bring this up here, in fact, if we just move everything to the left, then we would have 8y plus 3x when we move that 3x over, and also minus the 3 over would give us plus 13, and that is equal to 0. Of course, you could write this as 8y equals, or you could make it y equals if you wanted. The question might ask you to write it in different ways, but it didn't ask us to write it in a particular way, so just having it equal to 0, 8y plus 3x plus 13 equals 0, is probably the easiest way for us to write that answer. Okay, so when it comes to triangles in circles, there's a couple of different methods that you could use. Now you might be asked to find the centre of the circle. Now this particular question says to show that AB is the diameter of the circle. So of course that we could just find the midpoints of the point A and B, but if it wasn't the diameter of the circle and we were wanting to find the centre, then you could actually use the perpendicular bisectors of the chords. So if we looked at the perpendicular bisector of the chord AC, we would find the midpoint and then find the perpendicular line equation, which would go through the circle like this. We could then do the same with CB, finding the midpoint, and again the perpendicular bisector would cross through like this. Now those perpendicular bisectors do cross at the centre of the circle, so if you found the equation of those two lines, you could set them equal to each other. And of course we've already discussed looking at midpoints of lines and perpendicular bisectors, so that additional step there wouldn't be too much work. Now this particular question is slightly different. It's actually telling us to show that AB is the diameter of the circle. Now because that is the diameter, we know via circle theorems that if it is, this angle here must be a right angle, and therefore we could use Pythagoras to show this proof. So in order to use Pythagoras, we would have to find the lengths of these lines, so A to C and C to B. We could then use Pythagoras to show the length that it matches the length of A to B. So if we go about doing that, you can see from A to C, the length there goes from minus 8 to minus 4. Now that is a distance change of 4, so we would do 4 squared, and 1 to 9 is a change of 8. So if we did 4 squared plus 8 squared and square rooted our answer, that comes out as 4 root 5. So the length of that line there is 4 root 5. We can do the same from C to B. Now that goes from minus 4 to 4, which is a change of 8. And 9 to 5 is a change of 4. So 8 squared plus 4 squared for that length, using Pythagoras again, would give us 4 root 5. So that length there has a length of 4 root 5, which matches the length of A to C. So they are our two lengths, and if we do Pythagoras with those two to find the length of the diameter, that should match the length we get when we use this same process. So if we just do the same process using Pythagoras between these 2 points, then for a to b, you can see it goes from -8 to 4, which is a change of 12, and it goes from 1 to 5, which is a change of 4. And if we do that using Pythagoras again, we get the length 4 root 10. So that comes out as 4 root 10, and now we can have a look at showing our proof. So they are the definite distances. If this triangle is right angled, then if we were to square both of these sides and square root the answer, it would have to match the length of the diameter. So if we go about doing that, 4 root 5 in brackets squared plus another 4 root 5 in brackets squared, and if we square root all of that and we type that into our calculator, we get the answer 4 root 10. So as you can see, it has matched to the length of the diameter, therefore it is definitely a right angled triangle, and therefore thinking about circle theorems, angles made in a semicircle form that right angle, that 90-degree angle that we've shown, so it must be a right angled triangle, and therefore a to b must be the diameter. Okay, so that is the end of the video, looking at everything to do with circles. I do hope you found that useful and helpful. If you did, don't forget to like, comment and subscribe, and I'll see you for the next chapter.